Hello, everyone, and welcome back. So we're looking at square roots, powers, and exponent laws. Now, looking at this unit of these different topics, we want to first talk about square roots and what are the square roots. Now, you've probably seen this symbol before, but we haven't, and this is not long division. Okay, it's different. This is the square roots. And so over here, this first one over here that I drew, this is what we call the radical sign. Now, what is this radical sign? Why is it important? What's going on? It is really important because the key thing about a square root is that it tells me that what is the what is the like if I say for instance square root of 9, then the question I'm asking over here is what number multiplies by itself to get 9. Okay. So basically you're asking yourself like if we're doing a square root, which is typically the one you're going to be focusing on in year 9, is you're basically saying, okay, what number multiplies by itself to give me the number underneath the square root? Okay. So this is a radical sign, and the most common one that we're going to be talking about is the one with the imaginary 2. Technically, you don't need to draw that 2 in there. So you could just go, boom, that is the square root. Okay. So over here, right, the square root, where I don't have to draw this 2, but it's kind of understood that there is a 2 over there. And so it's kind of like when you say, for instance, let's say 3, right? 3 is understood to be 3 to the power of 1, for instance, or 3 is understood to be 3 over 1. These imaginary numbers with the square root, the first one of them is the one with the 2, where it says what number multiplies by itself to give me 9, for instance. Okay, and so this is what we call the square root, and we don't need that 2. So I'm going to even erase this 2. It's just kind of for you to understand that, oh, that's the one with the 2. Okay, so whether it's there or not, these two mean exactly the same. All right, they both mean exactly the same. All right. Okay, now I've included a chart of the perfect squares here because this 9, for instance, is a perfect square. And the key thing is that if the number underneath is a perfect square, then I'll have a whole number answer. I'm gonna have an answer that is easily solved. So a perfect square is basically a number with a rational square root, right? Remember rational versus irrational numbers. Rational number means if I put a square root if I put like, let's say 9, we know that the number that multiplies by itself to give me 9 is 3. So the answer to what is the square root of 9 is 3. This is a rational number. But if I were to do a square root of 10, for instance, this would give me an irrational number. All right, you can do that on your calculators. So this is going to be an irrational number. It's not going to be any of the rational numbers that we've discussed in the previous video. And so it's not any number that can be written as a fraction or a terminating decimal. So this is irrational, but this one is rational. And so when we're talking about square roots, if I have a perfect square underneath my square root, then I'm going to get a rational number as the answer. And so I've included this chart over here because if you look at the ones that are highlighted in yellow, you can see that 1, 4, 9, 16, 24, 36, right? All of these are perfect squares. And so because they're perfect squares, right, what we notice about them is that anytime I have the square root of any of these, well, it's basically telling me 10 times 10 gives me 100. And so what is that number that multiplies by itself to give me 100? Well, that's just 10, right? So if I go, for instance, what is the square root of 100? You ask yourself, what is the number that multiplies by itself to give me 100? Well, oh, that's 10. What's the square root of 81? What number multiplies by itself to give me 81? Well, that's 9 times 9. And so over here, when I ask myself what number multiplies by itself to give me 81, I get 9. If I do the square root of 36, for instance, well, what number multiplies by itself to give me 36? Well, that's 6 times 6 gives me 36, okay? All right. So this is pretty much it for square roots or radicals. Let's just keep it with the square roots. That's really just it for square roots. You just ask your number yourself. So you ask yourself what number multiplies by itself to give me the number underneath the square root, and that is your answer. Okay. All right, now you could obviously go to much higher numbers. Like I could tell you, what is the square root of 400? Now, that's not one of the common ones that we know, but what number multiplies by itself to give me 4, right? I like to think of it as the simpler one. What number multiplies by itself to give me 4? Well, that's just going to be 2. But what number would multiply by itself to give me 400? Well, I'd need 20. 20 times 20 gives me 400, right? And so the answer to what is the square root of 400 would just be 20. So some of them are simpler ones to do like this if they're not like the ones that you know, like up to 100, or you should actually know up to 11 times 11. Okay, so 11 squared, for instance, that's equal to 121, and 12 squared, that's equal to 144. Okay, so basically you ask yourself what number when I square it gives me this answer, and that's basically what we get, right? Because over here, 9 squared is equal to 81, and that's why the answer to what is the square root of 81 is equal to 9. Okay, all right, so that's oh, whoa, I was trying to erase it. So that's pretty much it for this section, everyone. Join me in the example videos where we're going to do a few more questions on this, okay? All right, I'll see you there. Bye.